SpaceX had never before successfully ignited all 33 Raptor engines at once, on a Super Heavy booster stage. At least 5 engines failed on the first Starship test launch in April, and multiple engines misfired on this Super Heavy booster, during hold-down test firings in August. The simultaneous ignition of all 33 engines was something SpaceX engineers were certainly elated to see. No rocket has ever fired so many engines together. The 33 Raptors put on a show, consuming more than 40,000 pounds of propellant per second, and generating nearly 17 million pounds of thrust. A 1,000-foot tongue of fiery blue-orange exhaust trailed behind Starship as it rocketed into a clear sky just after sunrise. Moments later, a deep rumble reached onlookers, including this, perched less than 4 miles from the launch pad. The rumble grew into a crackling thunder a few moments later. It's no surprise the world's largest rocket is also the loudest. The Super Heavy booster, itself as tall as an entire Falcon 9 rocket, used its 3 still-burning Raptor engines to turn around and fly tail first, then ignited additional engines to begin boosting back toward the Texas coastline. People keep pointing out that the booster RUD started in the middle of the tank, therefore FTS must have triggered. That's not necessary. If you've got fluid hammer effects going on at the base, then those same forces are being experienced along the downcomer, and up to the bulkhead between LOX and CH4 tank. A catastrophic failure like this could happen without FTS being involved. So, if we can trust the telemetry from Starship's flight, there was a significant negative G observed on the booster during staging. More force was transmitted to the booster than anticipated during hot staging. This would have generated a lot of propellant slosh, that may have been enough to damage the booster and ultimately cause it. One last observation. During hot staging the booster velocity drops rapidly for a moment. This is faster than can be explained by gravity. If this is accurate, the booster had negative G loading for a moment, possibly lifting propellant off bottom of tanks. It's very short, but still a bigger deceleration than I expected. In the first minute of flight, Starship surpassed the speed of sound and started heading downrange east from SpaceX's Texas launch facility, known as Starbase. All 33 engines continued firing until the command to shut down all, but 3 Raptors a little more than 2.5 minutes into the flight. SpaceX has invested in upgrades and extensive ground testing, to improve the reliability of the Raptor engine. Second-generation versions of the Raptor engine flew on Saturday's launch, replacing the less reliable first-gen Raptor, called Raptor 1. SpaceX is developing a Raptor 3 engine variant to fly on future Starship missions. Accomplishing a full-duration Super Heavy burn without any engine failures, is a significant step forward for the Starship program. Engine reliability was one of top concerns identified by NASA's Lunar Lander Program Manager, Lisa Watson-Morgan, in an interview earlier this week. She manages NASA's contract with SpaceX to turn Starship into a human-rated moon lander, for the agency's Artemis program. The Raptor engine is a beast. Each one can produce 500,000 pounds of thrust, about the same as one of the main engines on NASA's retired Space Shuttle, or the Space Launch System rocket. Raptor uses a full-flow staged combustion engine cycle, which comes with higher complexity but has benefits, such as higher efficiency and lower operating temperatures. This means an engine like Raptor, theoretically, is easier to reuse than any other large rocket engine. A new steering system also appeared to function as designed on the Super Heavy booster. Since the April test flight, SpaceX has replaced a hydraulic thrust vector control mechanism, with engine gimbals driven by electric actuators. Staging achievement unblocked. Then came the moment everyone was waiting for, hot staging. This maneuver was untried before Saturday's test flight. Most rockets disconnect their boosters from their upper stages without any engines firing. The first stage shuts down its booster engines for a few seconds, the stages release from one another, and then the upper stage ignites to continue accelerating into orbit. SpaceX settled on a new staging sequence, called hot staging, for the second full-scale Starship test flight. Russia uses hot staging for some of its rockets, but before Starship, there were no U.S. rockets currently using it. The Super Heavy booster turned off all but 3 of its engines, then the Starship upper stage fired its 6 Raptors at the same time. The booster stage separated to begin a descent into the Gulf of Mexico. The transition to hot staging on Starship will increase the rocket's payload capacity, according to SpaceX. In order to make this possible, SpaceX added a 6-foot-tall vented structure in between the Super Heavy booster and Starship upper stage. This allows super hot exhaust from the upper stage engines to escape the confined compartment between the stages, reducing the risk of damaging the booster, which SpaceX wants to eventually reuse many times. Hot staging appeared to be a success. Insprucker said the hot staging result was exactly what we were looking for. Remarkably, the hot staging maneuver was visible from the ground Saturday. Suddenly, a bubble of orange flashed around the rocket, which was, by this point, barely a star-like speck in the sky. SpaceX later released dazzling zoomed-in shots of stage separation, taken by a long-range tracker. The Super Heavy booster, itself as tall as an entire Falcon 9 rocket, used its 3 still-burning Raptor engines to turn around and fly tail first, then ignited additional engines to begin boosting back toward the Texas coastline. The booster was supposed to descend into the Gulf of Mexico for a controlled low-speed splashdown, but the Super Heavy disintegrated in the upper atmosphere moments after stage separation. Eventually, SpaceX wants to land Super Heavy boosters back on the launch pad for quick inspections and refueling for another flight. The April test flight ended before SpaceX could try out the Starship upper stage. On Saturday, SpaceX engineers had their first opportunity to watch their new ship fly in space. The upper stage lit its 6 Raptor engines and continued flying east from Starbase, eventually accelerating to a speed of nearly 15,000 miles per hour, about 24,100 kilometers per hour. Starship soared above the von Karman line, the 100-kilometer-high internationally recognized boundary of space, and kept climbing. Eventually peaking at an altitude of 92 miles, 149 kilometers, according to a real-time data display on SpaceX's live launch broadcast. Less than 30 seconds before the point at which the 6 Starship engines were supposed to cut off, SpaceX lost telemetry from the rocket. In the company's live video feed, it looked like the ship exploded as it was about to pass below the horizon from the viewpoint of the Starbase launch site. A few minutes later, Insprucker reported Starship's automated flight termination system, apparently triggered late in the upper stage's engine burn over the Gulf of Mexico. A weather radar in Puerto Rico detected what was probably Starship debris falling back into the atmosphere over the Atlantic Ocean. Had the engines completed their burn, Starship would have gained enough speed to circle the Earth for nearly one full orbit, before falling back to the planet over the Pacific Ocean for a targeted splashdown. That's it for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section down below. Your feedback is very important to us, because it helps us make better videos for you, so thank you very much and we hope to see you again next time.